Hello everyone. Today I am going to discuss about first normal form. What is meant by first normal form? Before going to the first normal form, what is meant by normalization? Normalization is a process of decomposition to smaller relations. There is a first normal form, second normal form, third normal form, fourth normal form, fifth normal form. Okay, first normal form states that it should be only simple or individual or atomic value. Okay, there is no multi-valid attributes. That is that the table should not have any multi-valid attribute. Multi-valid attribute is nothing but, observe here, there is a roll number, a name, course. That is the table name is the student table. Student table having roll number, name, course. That is a roll number attribute, name attribute, course attribute. Observe here roll number 1, name Sai, and then course C or C++. This is a multi-valid attribute. Okay, it should not contain multi-valid attribute. Okay, that's why this table, the student table, is not in first normal form. Is not in 1NF. Is not in first normal form. Okay, why? Because that is a 1 Sai, C or C++, 2 Raju, Java, 3 Kiran, C or DBMS. That is a multi-valid attributes. Okay, what is my first normal form? States that simple or individual or atomic value. Okay, that is the here the table should not have any multi-valid attributes, but here multi-valid attributes is there. That's why the table is not in first normal form. In GATE point of view, like that only may ask what is the table? The given table is not in first normal form. Okay, that's why we can different types of solutions, first normal form solutions. What is that? First one, that is a roll number, name, course. Roll number, name, course. What is the first one? Sai, 1 Sai, C, 1 Sai, C++. Second, Raju, Java. Third, Kiran. First course is a C, and then third, Kiran, DBMS. Okay, one students may join, that is a many courses. That's why here there is a first solution. What is the roll number, name, and then course? That is a 1 Sai C, 1 Sai C++, 2 Raju Java, 3 Kiran C, and then 3 Kiran DBMS. Okay, there is no here multi-valid attributes. What is the primary key here? That is a primary key here is the primary key. Primary key is the roll number, combination of roll number and then course. That is a 1 C, 1 C++, and then 2 Java, and then 3 C, and then 3 DBMS. Okay, that is the primary key is the, that is the roll number, course. Primary key is the combination of roll number comma course. Roll number comma course. That is a primary key combination here. That is the first solution. Okay, here there is no multi-valid attributes. This is a solution 1. And what about next one? Solution 2. Observe here. That is a roll number, name, course 1, course 2. And then here that is a 1 Sai, course 1 C, course 2 C++. And then according to our table, second Raju, Java, that is a null value. Null value means not 0 or not available. And then third Kiran, course 1 is a C, course 2 is the DBMS. Clear? This is second solution. Okay, observe here, what is here? Combination. Observe here, there is no multi-valid attributes. But here, what is here? Problem is this is the null. Sir, suppose one student can join many courses, null 1, null 2, null 3, like that only. Course 1, course 2, dash, course 3, course 4, course 5. Okay, this is not a good optimization in normalization. First normal form solution. Third case, observe here, it can decompose into two relations. First one is that is R1 and this is R2. The student table can be divided into two relations. One is a roll number, name, second table is the roll number, course. Observe here 1 Sai, 2 Raju, 3 Kiran. Okay, and whereas in the Second table, roll number, course, combination. Here 1C, 1C++, 2 Java, 3C, 3 DBMS. What is the here R1 table primary key? R1 table primary key. What is the primary key here? Roll number. Roll number. Primary key is a roll number. Why? Because uniquely identified within the entity set. Okay, this is the base table. Okay, what is the here? Second table, roll number. Roll number is reference to the base table. Is nothing but what? That is a foreign key. Foreign key. A reference table is nothing but foreign key. And what is here? In this second table, what is a primary key? Combination, roll number and then course. Okay, this is the best solution in first normal form. Okay, what is my first normal form? It should be states that simple or individual or atomic value, there is no multivalid attributes. Okay, that is the first normal form. And then whereas in the gate point of view examples, normalization techniques, that is a gate 2006. What is that gate 2006? The following functional dependencies are given. What are the functional dependencies? AB tends to CD, and then AF tends to D, DF tends to F, C tends to G, and then F tends to E, and then G tends to A. What is the functional dependency? F tends to CD, AF tends to D, D tends to F, C tends to G, F tends to E, G tends to A are the functional dependencies. What is meant by functional dependency? Functional dependency is nothing but X tends to Y. Y is depend on X. X compulsory key. Y may or may not. Okay, that is a functional dependency property. We know functional dependency and closure, we can easily solve this type of questions up to first normal form. Whereas in the second normal form, third normal form, and then fourth normal form, fifth normal form, that we will see one by one. This is a functional dependency. What is the property of functional dependency? T1 of x equal to T2 of x. Then T2 of y equal to, that is T1 of y equal to T2 of y. Here x and y are the attributes, T1 and T2 are the tuples. T1 and T2 are the tuples. Okay, clear? And which of the following option is false? Which of the following option is false? Based on, observe here, what is the first answer? CF closure, and then BZ closure, and then AF closure, and then AB closure. Okay, what is meant by closure? That is a simple example. Simple example, that is a comma B comma C. The given relation are A comma B comma C. A tends to B and then B tends to C. These two are the functional dependencies. A tends to B and then B tends to C. And what is meant by that is a closure. A closure. A closure is nothing but A derives what? B. B derives what? C. That is a closure. Clear? Here A is a candidate key or key. A is a candidate key. Okay, what is in by primary key, what is in by super key, what is in by candidate key? Keys concepts plays a very important role. Up to in this problem, what is in by key or what is in by candidate key? That is before going to the candidate key, super key. What is my super key? An attribute or set of attribute that has uniqueness property is nothing but super key. Clear? First A is a super key. That's why AB closure. Suppose AB closure. What is a AB closure? AB. First step is a AB. A derives B. B derives what? C. AB is a super key. And then, and what is the next one? ABC closure. ABC closure. You can get ABC. You can get the original relation. That's why A, AB, ABC are super keys. Okay. What is meant by key? What is meant by key here? That is a and then AB and then ABC. What is the minimal? Minimal is the A. That is a key. What is my candidate key? The set of all the keys in a relation is nothing but candidate key. For example, in student table having student name, student number, marks, address, and then Aadhaar card number. Okay, observe here, student table is the uniquely identified within the entity table. That's why student number is a primary key. But what about subset? That is Aadhaar number, driving license number. These are the subset of keys. That is a minimal super keys is called candidate keys. The set of all the keys in a relation is nothing but candidate keys. What is our question? Which one of the following option is false? Observe here, first one, CF closure. What is a CF closure? CF closure. I think you are familiar that CF closure. Simply we can write as that is a CF. CF. Observe here, what is a C? CF. What is a C derives what? G. C derives what? G. And then next F derives what? F derives E. F derives E. And then next G derives what? A. G derives A. And what is the here? C, F, G, A. And then next observe here AF, that is a AF. AF derives what? That is a D. Okay, observe things, that is a, AB derives CD, is there A, B, there is no B here. AF, that is a AF derives D. And then DE, that is a DE derives what? F, F is there. And then C tends to G, that is a G is there. And then F tends to E, E is there. And then G tends to A, that is a A is there. That is a here, CF closure. Observe here, CF closure, what is that? A is there, C is there, and then D is there, and then E is there, and then F is there, and then G is there. That's why first option is the true. First option is the true. But what is our question? Which one of the following option is false? Which one of the following option is false? Right. Observe here, second option. What is the second option? BZ closure. That is a BZ closure. BZ closure. And what is the reflective property? That is a BZ closure. That is a first one, BZ. Simply we can write as BZ. What is that? Observe here, BZ. That is a G derives what? A. Observe here, G tends to A. G derives what? A. And then what is the next one? And then AB. AB. A is there, B is there. AB derives what? CD. AB derives what? CD. AB derives CD. And then observe here, that is a C tends to G. G already is there. And then F tends to, there is no F here. And then G tends to A here. And what is a, A, B, C, D, G. A, B, C, D, G. Right, we can get the, option, that is the second option is also true. Second option is also true. Why? Because A, B, C, D, G. Here also, that is A is there, B is there, C is there, D is there, and then G is there. A, B, C, D, G. That is a true. And what about third one? That is a AF closure. That is a AF closure. AF closure. That is a AF. AF. What is that? Observe here. AF. AF derives what? D. AF derives what? D. And then next F derives what? F derives E. F derives E. And then next D derives F. Already F is there. And then next one, AB, no B here. And then next C, no C. And then F, what is the F derives E? E already is there. And then G tends to A, there is no G here. Okay, what is the C option? That is a, we cannot get the, this option. We cannot get. Why? Because A is there, yes. And then E is there, yes. And then D is there. And then next F is there. F is there. What is that? AF is D. And then D is F. D is F. And the next one, F tends to E. Okay, F tends to E. Okay. That's why here we cannot get the, original relation. This is the C is a false. C case is a false. Okay. Observe here what was the fourth option? AB closure. What is the AB closure? Here in this only AB closure. AB closure. What is the AB closure? AB. First one AB closure, AB. Observe here AB derives what? CD. AB derives what? CD. And then next C derives what? Check it, C derives G. C derives G. And then G derives what? A. A is already is there. And then C tends to G. Okay. And then next, observe here, that is a B, C, D, A, B, C, D, G. Okay, you can get the original relation. That's why this option is also true. Okay, what is A is true, B is true, and then D is true. But according to our question, which one of the following option is false? That is the AF closures. C option is the correct answer. That is the bit gate 2006. Okay, here if you familiar, that is a functional dependencies and closure. we can easily solve, that is a, first normal form and then second normal form and then third normal form. Okay, that is the here. Observe here the following functional dependencies. These are the functional dependencies. What is my functional dependency? Extends to y. Y is dependent on x. Okay, x is a determinant, y is the dependent. What is the property of functional dependency? T1 of x equal to T2 of x, T1 of y equal to T2 of y. Here T1 and T2 are the tuples, x and y are the attributes. Okay, and what is my closure? Simple example of closure. If you are familiar, that is a closure, you can easily solve this type of problems. Okay, that is a first question. That is a option C is the correct answer. Observe the next question. Move into the second question. That is a GATE 2013. GATE 2013. Observe here, relation R has 8 attributes. What are the 8 attributes? A, B, C, D, E, F, G, H. Fields of R contain only atomic values. Okay, that is a functional dependencies F equal to, functional dependency F equal to CH tends to G, A tends to BC, B tends to CFH, and then E tends to A, F tends to EZ. These are the functional dependency. Already told that what is my functional dependency. X tends to Y. Y must and should key, and then X and must and should key. Y may or may not be. That is a Y is depend on X. Okay, that is a X tends to Y is a functional dependency. That is a Y subset or equal to X. Okay, and then what is here is a set of functional dependencies, so that F closure is exactly the set of functional dependencies that hold for R. R is the relation. How many candidate keys thus relation? How many candidate keys? If you familiar keys, what is my keys? Super key, primary key, candidate key, foreign key, alternate keys, composite keys. Okay, and what is my primary key? Primary key is nothing but uniquely identified within the ND set is a primary key. For suppose simple example, in our class we know student name. Can you identify the all records? No. Why? Because student name is the repetition of information. Why? Because some students Raju, same name can appear twice or thrice. Okay, that's why. Okay, that is a name is not uniquely identified. Suppose we know marks. Can you identify the remaining records? No. Why? Because same marks can appear twice or thrice. That's why student number is a uniquely identified within the ND sets. That's why student number is a primary key. And what is by super key? Super key is nothing but an attribute or set of attribute that has uniqueness property is nothing but super key. Clear? Observe here, that is a super key, that is a R of A comma B comma C comma D. R of A comma B comma C comma D. And what is observed here? That is A tends to B, functional dependencies. B tends to C, C tends to D, functional dependencies. What is my functional dependency? What is my A closure? That is A closure. A closure. We can get the A derives what? B, B derives C, C derives what? D. Okay, that is A is a super key. Don't confuse. An attribute. That is an attribute, single attribute. We can get the original relation. What is the original relation? A, B, C, D. That's why A is a super key. A, B closure. A, B closure. A, B. A derives what? B. B derives what? C. C derives what? D. We can get the original relation. That's why A is a super key. A, B is a super key. And the next A, B, C closure. ABC closure. And what is the ABC closure? ABC. Reflexive property, that is how simply we can write as ABC first. AB closure, you write AB. ABC, that is a C derives what? D. C derives D. You can get the original relation A, B, C, D. That's why A and then AB closure, ABC closure are super keys. Suppose B closure, observe that. B closure. What is a B closure? Simply we can write as first B. B derives what? C. C derives what? D. We miss that is a value. We cannot get the original relation. That's why B is not a super key. Here super keys are A, B, ABC. An attribute is nothing but single attribute. Set of attribute means A, B, ABC. But according to our tabulation example, student name, student number, marks, address. In student table having student name, student number, marks, address. What is a student number is a uniquely identified within the entity set. That's why student number is a super key. And what is a combination of student number, student name is also a super key. Is a combination of student number, student name, marks is a super key. Is a combination of student number, student name, marks, address is also a super key. That's why super key is a definition, an attribute. That is a single attribute or set of attribute means AB, ABC. An attribute or set of attribute that has uniqueness property is nothing but that is a super keys. Clear? I mean, what is my candidate key? The set of all the keys in a relation is nothing but candidate key, or minimal super keys is called a candidate key. What is that? The set of all the keys in a relation is nothing but candidate key. What is that actual question? That is how many candidate keys does the relation R have? How many candidate keys? That is according to options, 3 candidate keys or 4 candidate keys or 5 candidate keys and then 6 candidate keys. I mean, based on the question, what is that here? I mean that observe here CH tends to G, A B tends to G, and then B tends to CH, E tends to A, and then F tends to E, G. Okay, observe the following things. Observe the following things. That is how many candidate keys are there? How many candidate keys are there? And what is the first one? A closure. Observe here A closure. What is that A closure? A closure, clearly A. Simply we can write as A. And then A derives what? BC. A derives what? BC. And then B derives what? CFH. C is there. FH. 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 What is FEG? What is FEG? What is FEG? And then what is that? A, B, C. I mean, what about that is A, B, C, D, E, F, H. The functional dependency are the following. That is holds. And what is that? A closure. What is that? A closure. A closure. That, and what is the next one? B closure. B closure. What is a B closure? B closure. B closure. B closure means that is a B. B derives C, F, H. F, H. And what is that here? F, E, G. F, E, G. And what is the next one? What is the next combination? Right, that is CH tends to G, CH tends to G is there, and then BC, and what is that? BC, right, B tends to CFH, E tends to A, E tends to A, you can get that is the A, right, we can get the original relation. C closure, what is a C closure? What is the next one? C closure. Or E closure and then F closure, E closure and then F closure. What is a E closure? What is a E closure? E derives, that is a EA, and then A derives what? BC, BC, B derives CFH, C already is there, CFH, and then E derives what? A is there, and then F tends to what? EG, that is a G. We can get the original relation. F closure, what is a F closure? What is a F? Derives EG, that is a EG is there, F derives, and then E tends to A, E tends to A, and then next A tends to BC, A tends to BC, A tends to BC, and then E tends to A CH tends to G, and what is a B tends to what? B tends to CFH, C is there, F is there, H. You can get the original relation. That is the 4 keys is there. This is the second option, correct one. Okay, this is the second bit gate example according to our syllabus. Okay, what is that here today? What is the first normal form? What is the first normal form says that it should be only simple or individual values. Clear? Okay, in next class, what is by second normal form? Okay, what is the importance of second normal form? Thank you.